Hello and welcome to this Python tutorial. So this tutorial is about giving you the solution of the homework, and at the same time this will teach you how to make a single prediction, that is a prediction of one new observation, which here happens to be a new customer of the bank that is not from the original sample, and we're trying to predict if this customer will leave the bank or stay in the bank based on its informations. So as you can see, I restarted my kernel because I'm going to re-execute the whole code in one shot because I would like to show you something else which will be a good transition to the next section about evaluating the model's performance. So let's do it. I'm going to select everything here. So as you can see, this is the whole code with the same data preprocessing phase, the same ANN architecture, and the same code for the predictions and the confusion matrix, and I just added a new code section here for the homework. But anyway, that's the same, so I'm going to execute, and here we go, the model is now learning. Alright, so while it's learning, we're gonna explain the homework and how we can provide a solution. Alright, so we're trying to predict if the customer with the following informations will leave or stay in the bank. So this customer lives in France. He has a credit score of 600. He is a male. He is 40 years old. He's been in the bank for 3 years. He has $60,000 on his account. He has 2 products in the bank. He has a credit card. He is active. And he has an estimated salary of $50,000. And so now we would like to use the model we built here, and that is actually training right now, to predict if this customer will stay or leave in the bank. So you already know how to make a prediction. You know how to use the predict method to make some predictions of some observations in one set, which was xtest. But do you know, is it obvious to make a single new prediction of one observation? Because I suppose that you used the predict method on one observation in an array, but did you figure out how to put the observation in this array? This is quite special, so that's what we'll figure out in this tutorial. And actually, it's really important to know how to make a single new prediction because, of course, when you make a model, you want sometimes to use it to predict a single observation. Alright, so let's do it for this customer. And so the first thing that we're going to do is give a name to a new variable that will contain this new single prediction. And so we're going to call it new prediction. So new underscore prediction. Here we go. And now, same as when we made the predictions of the xtest observations, we need to take our classifier and then use the predict method on our single new observation. So let's do it. Let's start by taking our classifier and dot, then predict, the predict method. So far it's the same. It's exactly the same as what we did here. This is now that things change because here it's easy, we have xtest, but here we have some informations of some customer that we don't really know how to input in an array, for the first time. So speaking of array, we have to put these informations in an array. Even if this is a single observation, we have to put this single observation in one array. And so how do we do that? Well, that's easy. We use the array function by NumPy. And how do we take it? We add here np.array, and in parentheses, we input the informations of this customer. But these informations have to be put in a horizontal vector, not a vertical vector. And why is that? It's because our observations in our dataset or even in our matrix of features are in lines, as we can see it. They're not in columns, so in vertical vectors, they are in horizontal vectors. So that's the same for our customer here. We need to put its informations in a horizontal vector that will correspond to a single observation, exactly like the observations that we see in this matrix of features. So let's do it. How can we put these informations in a horizontal vector? Well, the trick is to use a double pair of brackets. And why is that? It's because if you put a single pair of brackets, then the elements you'll include in the single pair of brackets will appear in a column. But if you add a second pair of brackets here, then this will create a two-dimensional array, and so you'll be able to put your elements in a first line of this two-dimensional array. A first line that will be the only line of this two-dimensional array. So in fact, we are recreating a next test, but with only one line. And that's exactly what expects the predict function. It expects a two-dimensional array, whether it has only one line or several lines. And each time the lines correspond to the different observations for which you want to predict the dependent variable. Okay, so now we have the good format. That's good. And now we need to add the informations. So here we go. First, what we must do is to put the informations in the same order as the order of the features in the matrix of features. So the first thing to do was to check that the informations that I gave you here are in the same order as in the matrix of features or in the dataset. So I confirm that they are in the same order, and therefore let's input them one by one. The first information we need to input is the information on the geography. That is the country where the customer is. So this customer is in France, and so right now we need to input the country France. But remember, the country France was a categorical variable that we encoded in dummy variables. And in this array, we need, of course, to input the dummy variables. So now we need to figure out what pair of dummy variables corresponds to the country France. And to see this, that's very easy. We need to take our dataset and our matrix of features. Here we go. Let's put them next to each other. And so since we have the same customers between this dataset and the matrix of features, well, we just need to see a customer that lives in France. That's, for example, the case of the first one with a credit score of 619. 619 here, that's the same customer. And see the dummy variables that this customer has. And so as we can see, this customer has the two dummy variables equal to 0. And therefore, that's how we get the values of our two first variables that are the dummy variables. All right, so perfect. Let's input that. And let's move on then with the next information. So the next information is the credit score. And here, no encoding was done, so we can directly put 600. Perfect. Now next information is the gender, the male. So here same, this variable was categorical, and therefore we need to check if male is 1 or 0. And to do this, we simply need to take our dataset again, see the first customer. The first customer is a female, and so if we go to our matrix of features, we see that female corresponds to 0, and therefore male corresponds to 1. So that's a 1 here. Next information is the age, 40 years old. So no encoding was done, so we can directly put 40. Then tenure, 3. That's the same. And now balance, 60,000, 60,000. All right, then number of products, 2. Then has credit card, yes. And of course you can check yes is encoded in 1. So we add a 1 here. And that's the same for is active member. Yes, that's an active member. And so the value for this is 1 as well. Okay. And finally, estimated salary, 50,000. Perfect. So now we entered the different informations of this customer as one observation line of a two-dimensional array, which is exactly what the predict method expects. Okay, fine. And now, are we ready to execute this to get this new prediction? Well, try to think about it for a second. The answer is no, actually, because here we input our informations in the original scale of the data. And remember, our model was trained on XTrain, and remember, XTrain was scaled. We applied standardization on it. And so since our classifier was trained on a different scale, well, when we make our new prediction, it has to be made on the same scale. And therefore we need to put the informations here of our customers onto the same scale. That must be the exact same scale as the one that was applied right here for the training set. And so how do we apply the exact same scale? Well, that's very easy. We take the same SC object because this SC object was fitted to the training set. So the fact that it was fitted to the training set means that when we apply it on any other set, well, this other set will get the same scale. So let's do this. Let's apply the SC object to our single observation here. And so since we have to apply it to the whole array, well, we need to use it here. SC dot, and now we use the transform method, and we put all our array inside this transform method. And this will scale our horizontal array. All right, and now we're ready to get the prediction whether this customer will leave or stay in the bank. But remember, when we use the predict method for the first time, we get the predicted probability that the customer will leave the bank. So what we need to do is the same as what we did here. We need to take this line to get the final prediction, true or false, whether the customer will leave the bank, yes or no. And of course here we replace ypred by new prediction. So I'm replacing that here and here as well. And now we are ready to get the solution of the homework, that is whether the customer left, yes or no, the bank. So here we go. We get a warning because our inputs are integers, and by applying standard scalar, it converted the data into floats. So if you don't want the warning, you can just put one element as a float this way. Just one is enough. And now if I reselect this, the warning disappears. Perfect. And so now what is our final prediction? Well, our new prediction is false. The customer doesn't leave the bank. Congratulations to this customer. Well, I hope the bank is okay, but here it is. That's the solution of the homework. Congratulations for those of you who figured out the solution. I think the most difficult part was to figure out how to use the NP array with the double brackets here, and of course to not forget to use the transform method to apply the same scale that was used for the training. Okay, so that's the end of the homework, and now the transition to the next section is this one. Remember when we trained our artificial neural network for the first time, we obtained 0.85, I think, in the end at the 100 epoch, and now by retraining it we got 0.83. So that's the accuracy of the training set, and then if I want to get the accuracy of the test set, I just need to, execute the confusion matrix. The confusion matrix is here. We get 1548 plus 137 correct predictions, which gives us 1548 plus 137 divided by 2000 to get the accuracy, and we get a test set accuracy of 0.84, and last time we got 0.86, I think. So this is to say that measuring the accuracy on one single test set is not the most relevant way to evaluate the model's performance, because by retraining the model several times, we get different accuracies, not only on the training set, but also on the test set. So we need to figure out a better way to evaluate the model's performance, and that's exactly what we're going to do in the next section about performance evaluation, and the solution to this is k-fold cross-validation. So that's exactly what we'll study in the next section, and then we're going to have even better. We will learn how to improve our model's performance, tune them so that we get the best architecture with the best hyperparameters, and we will judge on the best model with this more relevant model performance evaluation, which is k-fold cross-validation. So you're going to make huge progress with the next two sections. I can't wait to show you these powerful techniques, and until